Doo-doo-doo-doo. Fuck. How the fuck? How does it actually look like? Why is my aspect ratio fucked up? Fuck's sake. How the fuck? How does it actually look like? Why is my aspect ratio fucked up? Fuck's sake. Why can't I stream? Oh my god. What is up with this shit? Fuck. Settings aspect ratio. I need to find the aspect ratio. Fuck. Okay. Should I like turn the light on? Maybe. This is a. Wah. Yeah, the setup isn't ideal, but we must keep going on. Should I use a mouse? Should I use a mouse? Probably not. Mouse is gay. This is what you do with a mouse. Never use them again. Fuck mouse. Mouse. This is some. Let's go. Let's try this. Should I do linked list? I think I should be doing stack now. So let's go. Where the fuck is neat code? Okay. I'm gonna get some. Fuck. Is this on? Probably. I should go blind. For fuck's sake. Let's look at this. Get the rocks! Okay, let's do baseball game. This thing. Okay, types of stack question. Let's. I actually like doing this way. Can you guys see me? Or you guys can see me. That's cool. It's fucking cold as hell too. Give me a second. Inshallah, wabakalaf jumba. Yalla sha. Okay. Let's do this the way God wanted us to do this. Baseball game. Let's read the question. You're keeping the scores of a baseball game with strange rules. Interesting. At the beginning of the game, you start with an empty record. Given a list of strings operation, where operation I is the ith operation you must apply to the record, and it's one of the following: an integer x, record a new score of x, plus record a new score of. Okay, I need to record x plus d c. If it's a double, I need to score a d. Okay. So 5 plus 2 plus 1 plus what is c? Invalidate. Okay, bro. What is going on? New score. X is new score. This number is a new score. 5 plus. I need to double the previous. That will be 15. Record a new score. That is the sum of previous two scores. That will be 15. 30. And this kind of like cancels it out. Let's do a smaller example. Oh, fuck's sake. 3 plus 3 plus 5. Okay, 5, that's 8. Cancel that. No, don't cancel that. Okay, cancel that. 10. Okay. Let's look at the solution. It's just...
Hey everyone, welcome.
I have to change some of the... I'll do on the fly.
Back and let's write some more neat code today.
So what is the question? It's 682. Nothing new. 682, nothing new. 682. We got I think I'll finish it easy. And this will be a stack question. Let's go.
So today let's solve the problem baseball game, even though this has practically nothing to do with baseball. Maybe that's why it has so many dislikes, because
yeah, like what even is that? Like, I don't know.
Other than that,
baseball. Cricket is like the OG game. They kind of bit off of it.
I think it's a pretty good problem. It's very logical. There's no crazy tricks behind it, but I'm just going to skip the first paragraph because it's pretty useless. If this problem teaches you anything, it's basically how to kind of filter out the unnecessary information when you're reading a problem, which is actually a somewhat useful skill.
Yeah, this is like the main important thing anyway. So give me a second. My hands are fucking cold. It's cold out here, man. It's cold.
So at the beginning of the game, we start with an empty record. We're given a list of operations where each of the operation could be one of the four following. It could be some integer given in the form of a string. As you can see, they don't really mention that, but yes, it's given as a string. In this case, there's 5, there's 2. Now they mention at the bottom of the problem that the integer itself could be, I think, a value somewhere between -1,000 and +1,000. So it might not just be one digit, so you have to kind of keep that in mind. But the other 3 operations are, one is a plus symbol. What that means is we're going to add the 2 previous scores that we were given in operations together. And we're guaranteed that there are going to be at least 2 previous scores. So one thing we're kind of learning is that we're going to need to kind of memorize what the previous scores were, at least 2 of them. And the third
let's go easy problems only. Let me think. I could like probably do a higher overview of all of this. I'm such a real nigga. I move and talk like a real nigga. That's the difference too. Let's easy problem only. Okay. I need to like find a way to not only do this. Okay, if stack this thing, stack dot append. Okay, stack is just like a normal. Let's hear him say it, but give me the roadmap. So yeah, like I'm pretty much on there. I think I need to like get good at the binary search again. I think binary search kind of like overlaps with, weirdly, it overlaps with stack. And if I'm able to do this, I think trees would be like much more easier. Trees, the optimal track for me is to go trees backtracking. I don't need to do tries. I might do it, but trees backtracking graphs, and from there, and to go advanced graph. This is the tree that I want to go in, but I want to get to like advanced graph at least. But for that, I need to master the top 4. So let's go here.
Third one is a D. That means we're going to double the previous score, the single previous score. And it's guaranteed that there will be at least one previous.
I think I can do this already. I don't need a. So are they giving me? So they're giving me the operations already. So let's go stack. This will be an empty stack. Fuck. So for I in operations, I need to go if I just need to like look at the thing. If it is how do I like, if it is a type, it's not even an integer though, that's the thing. If it's a probably doesn't work, but append, what the fucking name? What will we get? Yo, sugar. Sum. Okay. How to check whether it's an integer or not? How do I check it? I mean, I don't have to, but I can. Stack dot append everything. I'm just appending everything. So if it's how do I check if it's a plus? If I is equal to a plus is equal to, I want to kill this bitch. I'm gonna do record a new sum of previous two, so it's gonna be I minus, it's gonna be sum of previous two, so it's gonna be stack dot append I plus, no, sum of the both of the, what, stack minus 1 plus, it's a sum, right? No, it's operations, fuck's sake. Holy shit, just give me operation, bro. Holy shit, bro. Holy shit, what's happening? Okay, that'll be the first one. Let's go if else if. We're just appending all of that and just returning the value at the end. I don't even know what it's called. So let's go here and let's do capital D. It's gonna be stack dot append. And this one is going to be record a new line that is double the previous score. So I need to record a new line that's double the previous score. What the fuck does that mean? So I need to record a double the previous two score. What even is D, bro? What the fuck is D? Why are you doing -1? That's stupid. First of all, why am I doing an S? It's just gonna be. Oh, it's in the stack. Shit. We are stacked out appending it too, so yeah, that kind of makes sense. Okay, it's gonna be stack, it's in the stack. Okay, -1 comma, no, it's plus stack minus, it could be like reverse, doesn't really matter, I think. And D is going to be double, so it's 2 into the stack of previous. It's going to be -1 stack. That's the first time I'm seeing the data structure, so don't really judge me on that. Okay, let's go this one. And it's going to be C. It's going to be minus. No, don't delete pop. So pop means the first one goes out. Okay. C. Schmuckles. Stack dot append. No, stack dot pop. I need to pop the last one. And else would be any numbers. I'm just gonna. What should I do? I'm not looking at the solution. So what should I do with the numbers? I think I'm just gonna append stack dot append. I need to append the integer. of I. And after all of that, I need to return the sum of stack. Let's do it. What's wrong with that? Oh, I is gonna be. It's gotta be something else, right? It's gotta. I is gonna be a number, okay? Now, what's wrong with that though? What's really wrong with this? I don't see anything wrong. It's exactly the same code. Literally, what is going on? Why is it op? I don't get the op. Stack 2, like what? What the fuck are you talking, bro? What the fuck are you talking? Okay, let's look at this. The types of stack operations. Yeah. Types of stack operations. I'm gonna like elbow someone. Valid parentheses, cool. Min stack, cool. Implementation queue using stack, cool. Valid palindrome stack. Bro, what are you talking? I'm talking about this Storm and okay, simple stack. So I'm doing 682. So it should be I wanna kill. Bro, it's literally the same thing. I don't know what you're expecting from me, bro. I wanna like elbow some people. Can I do that? Can I like low key do that? What even, bro? That's not even a thing. I'm telling you, that's not even a thing. Ban that, man. Whoever is in charge of that, ban that. What's wrong with that? I don't get it. Like, bro, literally the same thing, man. Man, this is the same thing, man. Literally, man. The same thing, man. How the what? Like, what? Let's go here. What's the difference? Literally, bro. Like, what's the difference? I don't get it. Like, what's the difference? Like, so I put like this. This is like wrong, bro. Fucking, you gotta be kidding me now. So I don't even know what to write on this. So I'm gonna use the pop if needed. Use the pop to get the last number. 628. Yeah. My grandma would do. I don't like my color pixely. Monotonic stack, increasing and decreasing stack. Stack indices. Bro, only easy, nigga. Okay, let's look into the next thing. Val in parentheses, bro. Come on. Stop playing them like that, man. Stop playing them like that. I think I can do this. Am I doing like 2 loops? Okay, close. Let's look at that one more time. So my stack is empty and I need to go all over the close. I have to check. The stack is equal. What the fuck is C, bro? C is this shit over here.
Hey everyone, welcome back, and let's write some more neat code today. Today let's solve an easy problem, valid parentheses. This is such a common interview question. I think I've been asked this so many times, like in phone interviews and online.
Phone interviews?
And assessments and stuff, so definitely a good problem to understand.
Bro, when was this video even released? Four years ago. 4 years ago, the world was sunshine and rainbows. Now it's just like 20 billion Indians fighting for your job. Me including.
We're given a string S containing only these 6 characters. They're basically parentheses type characters, right? Brackets, parentheses, closing. And there's 3 pairs, so there's an opening one, and then there's a closing one, and that's true for each of the 3 types, right? Open, and close. And our only goal is to determine if the input string is valid or not, and it's valid if the open brackets are always closed by the same type of bracket, and if the brackets are closed in the correct order. So if that's true, then it's valid, and we can return true. If it's not, then we can return false. So first example. Now, is this valid? Well, we start with an opening parenthesis, and then we close it with a closing parenthesis. So it happened in the correct order, right? This was closed in the correct order. Every open has a matching close, so this is valid, so we can return true. Obviously, if the order was opposite like this, it would not. We would have to return false because, first of all, this opening bracket isn't being closed, right? It's never being closed. The closing needs to go on the other side of it. So we have some unclosed parentheses, and it's basically in the wrong order. Let's look at this other example. We see, okay, opening parenthesis, then it gets closed, right? Okay, now we don't have to worry about these 2 anymore. Opening bracket, and then it gets closed, so we don't have to worry about that anymore. Opening curly brace, and then closing curly brace, so we don't have to worry about that anymore because they were all closed, and they were all closed in the correct order, so we can return true. What about something like this? See, we have an open parenthesis, and then we have a closing parenthesis, right? So then this is closing this one. And we have an opening bracket, and we have a closing bracket coming after it. So, right, this closes that, but this is wrong, right? This is not valid, and the reason is the order is off, right? We see that this closing parenthesis is actually being applied to this open bracket, but these do not match each other, right? So these don't cancel out. So this doesn't work. Basically, the order is wrong, and that's pretty self-explanatory by looking at it, right? It just doesn't look right. So now how can we actually determine an algorithm to be able to solve this problem? Well, one of the first things you might notice is we have to start with an opening parenthesis. We can start with this, we can start with an opening bracket, or we can start with an opening curly bracket, but we can't start with a closing parenthesis, right? Because like this is never going to be valid. We can't add any more stuff over here that's ever going to make this valid, right? It's not being applied to any opening parenthesis, so we can't start with a closing parenthesis. We have to start with an opening parenthesis of any kind. And once we start with an opening parenthesis, we can pretty much add as many opening parentheses as we want, as long as we're eventually closing them, right? So if we have 4 open parentheses, we have to have 4 closing that come after it. As we add a closing parenthesis that matches, right? So these 2 match each other, they counteract. We can then remove them from consideration, right? We can remove them from our list, right? So now let's say we get another opening parenthesis. We see it's being applied to this one, right? And we can remove these 2 as well. And we can keep doing that. So remove this and this, and add one last closing parenthesis so we can remove it along with that, right? And once we're done removing that, if at the end we have an empty list, right? Like let's say this is our list and it's empty, then we know we can return true because we closed all our opening parentheses. They matched each other and everything went right. Also, notice how as we add closing parentheses, right? So this one, and then we have to remove from the beginning of our list, right? So now let's say we remove these, right? Now let's say we get a closing bracket. Okay, we got to remove it, and we have to remove this one. So we're always going to be removing from the end of the list.
Shit. I didn't mean
to match to the open. So let's say we had this closing parenthesis, right?
So I need to use a hash map for it. I don't believe in it, bruv. It's hard to believe in it, bruv. So we're going to do 20. Let's go TDD 20. I'm gonna do stack. Only easy. Only easy. No hard questions ever. Never doing no hard questions ever, bro. Ever, bro. That's the valid parenthesis I'm gonna do. Okay.
Right, we'd go up into our hash map and check, okay, this closing parenthesis matches this open parenthesis. Okay, well, what was at the top of our stack? This is at the top of our stack, right? This other closing parenthesis. So since they do match each other, we can cross them out. We can pop from the stack, right? Now let's say we get what happens to be an empty. So with that through them, it's going to be the close. I'm going to map it to and closing and popping from it and just going through every map. That means it's a closing parenthesis. And the reason why is because every key of this map is always a closing parenthesis. So if this is a closing parenthesis, we want to make sure that our stack is not empty, right? We cannot add a closing parenthesis to an empty stack, and we want to make sure that the value at the top of
Let's see how he does it. Oh boy.
Hey guys, Greg here. Let's solve lead code 20, which is valid parentheses. It is a very, very common interview question, and it is going to use a stack. So we're given a string S, and it has only the characters of round brackets, curly braces, or square brackets. So it's just a bracket string, and we want to determine if that input string is valid. An input string is valid if it satisfies all 3 of these criteria. So number 1 is open brackets must be closed by the same type of brackets. So if you open the first, now we can open with whatever rules we have to satisfy.
We saw.
Again, so at all, and brackets on it. So we're going to iterate through the string, and when we see an open bracket, like we do right here, we're going to just put that on the stack. And by the way, when I draw the stack, I mean it's going to build from left to right. The top of the stack is going to be at the far right. So here, that's fine. We put that round bracket on the stack. We see another open bracket, and so we are going to put that on as well. Now, when we get over here, this is a closing bracket, and we're not going to put closing brackets on the stack. We are going to pop things off the stack when we see a closing bracket. So firstly, we need to make sure that we actually have a bracket available to pop off the stack. If we didn't have anything on the stack, well, that would mean we're trying to close too much. It means we're closing when there's no open brackets available, and so that would also be a scenario where we return false. Now, our stack is not empty, so we can pop something off. So we'll pop this thing off here, and we need to make sure that this is the bracket that matches with this one right here. This square bracket expects you to close with this one, and so it is is the correct match, and so we move on. If that wasn't the right match, so let's pretend that this was actually a curly bracket, we need a match for this closing bracket, we pop off and we see this, and we see, oh, that doesn't match, and so that would ruin scenario number 1. Open bracket is not closed by the same type of brackets because it's closed by the wrong type of bracket. But they did match, so we're going to move on. Here we see the round closing bracket, so we're going to pop stuff off the stack. Firstly, we check to see if our stack is empty. Luckily, our stack does have something. If it was empty, we'd return false, but it's not, so we pop it off. We were looking for a match with this one. This is the correct matching bracket, and so this is totally fine. Now here we get to the end of the string, and we are done. We just need one final check. We need to make sure that our stack is empty, and we need to make sure the stack is empty because if there was something left over, say a round bracket here, well, that would be this situation where we have an extra round bracket. We had no issues with the closing. It's just that we have some straight opening, and so because of that, if we had that opening in the stack still, that would ruin rule number 1. Open brackets must be closed by the same type of brackets. We're not closing it at all. Okay, so let's write the code. Now the first thing is we want a hash map. This is not necessary. This is not an efficiency type of thing. It's just very useful to have this where we have a dictionary that maps each closing bracket to its corresponding open bracket, and we'll see why we want that shortly. And I'm just going to copy this in here. We have closing round maps to open round, closing brace maps to open brace, and closing square maps to open square. By the way, we actually have in the constraints that the string only consists of these types of characters, so one of these things is the only thing we're ever going to run into. Now in Python, the easiest way to build up a stack is just to use an empty list, and that's why I wrote it from left to right there. We append when we want to put stuff on the top of the stack, and we want to pop, which is going to take it off the right side, so we're always appending to the right and popping from the right. That gives it that last in, first out, or LIFO quality, where the last thing that goes in is the first thing that gets popped off. Now we want to go for each character C in the string. We will see if C is not in the hash map. Now what that means is it is an open bracket because we have closing brackets as our keys and open
If C not in hash map.
brackets as our values. So if C is not in the hash map, that means keys and open brackets as our values. So if C is not in the hash map, that means it is an open bracket. If it's an open bracket, our iteration is very simple. We simply stack.append to C.
If C not in hash map. What the fuck is C? What are we doing? Okay, if the... Okay, I need a pen and paper. Fuck you. Fuck you. I wanna fuck. So, let's take this. Man, I have like a, I don't know, like really big. So let's take so S is gonna be this shit. And for S for C, so this is gonna be the first one. What if it's not? If this thing over here, if it's not in hash map, which is, how the fuck is that even possible? So the opening bracket, if it is not in the hash map, How the fuck is that even possible? It should be in the map.
Open bracket, we just want to put it on the stack, and we don't even care what it is. Now, if that's not the case, so that means C was in our hash map, we are dealing with an open bracket. If we don't have...
Yeah, thank you, bro. Thank you for making it that so fucking clear. That was so clear.
That means C was in our hash map, we are dealing with an open bracket.
Okay, that is...
To C. If it's an open bracket, we just want to put it on the stack, and we don't even care what...
Okay, if it's an open bracket, if it goes in the stack. Okay, if this thing is over here, so open bracket goes into the stack. If it's a closing bracket...
It is. Now, if that's not the case, so that means C was in our hash map, we are dealing with an open bracket. If we don't have a stack, so if our stack is empty, that's what this means, well, we can immediately return false.
If not, stack.
Well, we're saying, hey, we want to pop an open bracket off the stack because we have a closing bracket, say this one, where we want to find its match. But if we don't have any open brackets available, well, that means we have too many closing brackets, so we've got to return false. Now, if we do have a stack, we just need to check if it's the right value and pop it off. So we'll say popped is equal to stack.pop. That is going to take off the most recent open bracket on the stack, and we need to make sure that it is the correct one. By correct one, we mean if the
Convoluted in this fucking Java. You're a geek. You're a peasant, bruv. You're a peasant. Oh my god, you're a peasant. Implementing stack using queues. Okay, let's look at this. Monotonic stack. Two stack technique. Stack indices. Monotonic stack. I need to look into this. Monotonic stack. What is a monotonic stack?
Possibly one of the most confusing yet useful ideas for problem solving in coding interviews is the monotonic stack. In this video, we're
I think it's all used in YouTube recommendation algorithms, I think. Monotonic stack. Computer graphics, okay. Weather forecast, hotter next day. Stock price analysis, okay. Now we're talking, bro. Now we're talking, okay. It's monotonic stack.
going to show you an example and summarize it, so make sure to stick to the end. The monotonic stack is, as you might have guessed, a stack, which uses some greedy logic to keep the elements in the stack orderly after each new element is put onto the stack. What kind of order are we talking about? It could be either monotonically increasing, which means the elements either increase or stay the same as we go left to right, or monotonically decreasing, which means that it either decreases or stays the same as we go left to right. Let's look at an example. Given the heights of 5 people, find the height value of the person with the next largest height. If there is no larger height, store -1. Let's think about the brute force solution first. For each height, iterate through the rest of the array to find out the next greater height. The time complexity would be O of n squared, but do we really need to loop through the entire rest of the array? We're going to iterate from right to left and use a monotonic stack to keep the higher people on your right. In this case, we're going to be maintaining a monotonically decreasing stack. Every time we put an element into the stack, we still want to make sure that the stack is monotonically decreasing. We have 2, 1, 2, 4, and 3. So, of course, once again, we're going to be moving from right to left, and we're going to have our stack which maintains the greater values than the current height. So for example, if we were to deal with this 3 here, and this 3 pertains to this person in the blue on the right here, we see that the stack is empty. If the stack is empty, that basically means that, okay, nothing is greater than 3 so far. Or the so saying red person and mono side. So 4. Next, the answer of height means monotonic. That's greater. Increasing, put this right, Okay,
This is like one of those card games that I used to play back in the day.
but this is still not decreasing before. So we put the 2 in.
Yeah, it's one of those like stone games too, isn't it? You need to like get the big stone, smaller stone, smaller stone, smaller stone, tiny stone at top. Yeah, similar to
And that's
that.
our final step.
That's like the monotonic stack. Okay. Yeah, it could do. I think it could like flip the thing too, doesn't it?
Monotonic stack, a powerful pattern that shows up in lead
When that accent comes in, you just know you're gonna get the most pristine knowledge on algorithms. I'm telling you.
code problems where you need to find the next greater, next smaller, previous greater or previous smaller element in an array. If you go on LeetCode, there are currently 65 problems tagged with this approach, which shows that it is an important topic to learn for coding interviews. Using this pattern, you can reduce the time complexity of many array-related problems from order of n squared to order of n. In this video, I will share what a monotonic stack is, a generic template for solving monotonic stack problems, how to implement it in code. Plus, I will walk you
I just want to beat this guy up. I don't know why.
through multiple LeetCode problems to help you understand it
beat you
better.
up
I will also
for
share a
free?
resource where you can practice more problems using this pattern. So let's get into it. What is a monotonic stack? A monotonic stack is a stack that keeps its elements in a specific order, either always increasing or always decreasing. In a monotonic increasing stack, each new element you push is larger than the ones already in the stack. Using a monotonic increasing stack, you can solve problems which involves finding the next smaller element or finding the previous smaller element. In a monotonic decreasing stack, each new element you push is smaller than the ones in the stack. Using a monotonic decreasing stack, you can solve problems which involves finding the next greater element or finding the previous greater element. A quick tip: in most problems, it's better to store the indices of the numbers in the stack rather than the actual values.
Bro, my shit is fucking cooked. Barely fucking
This
works.
gives you more flexibility when
Daily temperatures, is that yo, stop tweaking. My shit is always tweaking like this. Crazy. Practice stack, monotonic stack, daily temperature, no? Implement stack using queue, implementing queue using stack, whatever the fuck that means. Okay. Okay, bro, what is going on here? What the fuck is going on here? What am I looking at? Billionaire, nigga. Who the fuck is gonna thinking this guy's a billionaire? Come on. He's a high level coach. Yeah, bro, I respect this guy. This guy's really good. Really good MMA coach. Okay, give me a stack shit, man. Stack is just
Google is the
stack. The types of stack, all of the stacks needed, this and that. What a stack? Stack questions.
Hey guys,
game,
great.
That's cool. Daily temperature. How about that?
Hey guys, in this video.
Nah, bro, I'm not doing medium questions. No fucking way. Even valid parentheses, I'm like, okay, for C in S, I need to go if it is not in close. Fuck, I can't even autocomplete. It's gonna like copy the entire thing. I'm telling you, it's fucking pissing me off. If it is not in this thing, open to close, I'm gonna append stack dot append. append C into that. Else, it's either if just, let me just give me the.
Deal. What's
Hello everybody, I'm Richter.
Nigga, okay, cool. Fuck off. Valid brackets, nigga, valid parentheses. Generate parentheses. It's medium, man. I can't do medium.
Problem number 20, valid parentheses. We are given a string S containing just the following characters. Determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets, open brackets must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. For example 1, our input string is open and closed parentheses, and that is valid, so we return true. For example 2, we're given open and close for each type of bracket correctly, and this is also valid, so we return true. And for example 3, our input string is data structure that follows a particular order in which the operations can be performed. The order in which you can access items on your stack is LIFO, which is last in, first out, and you can perform push or pop operations on your stack. Push will put a new value onto our stack, and pop will pop off the top value of our stack. So for this problem, we will be pushing open brackets onto our stack, and when we receive a closed bracket, we will pop the top value of our stack and compare it to our closed bracket we're seeing. And if they're the same bracket type, we'll know it's a valid set of brackets. Otherwise, it'll be invalid set of brackets. Going through our example, the first bracket we see is a open curly bracket, so we will push this onto our stack. Now we have a closed bracket, so we will pop the top value off our stack and compare it to see if it's the same bracket type as our current bracket. These are valid brackets, so we will continue through our string. Now we have an open parentheses. Since this is an open bracket, we will push it onto our stack. Now we have another open bracket. We will push this onto our stack as well. Now we have a closed bracket, so we will pop the top value off our stack and compare it. These are a valid set of brackets, so we'll continue through our string. And now we have another closed parentheses, so we will pop our top value off our stack again and compare. These are valid parentheses. And since we're at the end of our string, we know that we had a valid string because all of our set of brackets were valid. Let's go through another quick example. This time our string is open parentheses, open curly bracket, then closed curly bracket. The first character is a open parentheses, so we will push it onto our stack. Our second character is an open curly bracket, so we'll push this onto our stack as well. Our third character is a closed curly bracket, so we will pop the top value off our stack and compare. These are valid brackets, so we can continue. But since we've gotten to the end of our string and still have values on our stack, we know that these brackets in the string are not valid, and we'll return false. Let's jump into the code. First thing we want to do is define our stack. Next, we'll define our map, and this will be used to link our closed and open valid brackets to each other. Now we'll want to loop through our string. Now we'll check to see if our current character is in our map. If it's in our map, that means it's one of the closed brackets. And if it is one of the closed brackets, we want to pop the top value of our stack and compare it to our current character. And if they're a valid set of brackets, we will continue. But if they're not, we'll return false. And if our character is not in our map, we know it's one of the open parentheses, and we'll want to push that character onto our stack. And at this point, we're done with our looping, and we will want to return true if our stack is empty. Push the brackets, we will continue, but if they're not, we'll return false.
Stack -1 is equal to mapping character. What the fuck does that mean? So it means hash set, bro. What is going on? I don't understand this. Oh my god.
Hi guys, there are a couple of opening brackets and
base cases. So let's actually do it and let's see how it is. We keep continuing. So when we say yes, string is valid. If stack was not empty or if some of the condition didn't match, we say string is invalid. So let's look at an invalid example, and then we'll understand more. So similarly, let's draw a stack. Okay, so now opening bracket, opening bracket, opening square bracket, opening square bracket. So our stack would become here, it matches. Again, second closing bracket. So we'll pop from stack and it matches. Now we hit closing,
Pretty much
invalid. This algorithm
on the whiteboard. So we just iterate through all the characters in the string array, and for each type of opening bracket, what we do is we push the respective closing bracket in stack, and then
Java is so gay. I still don't get it completely. Ow.
Welcome to LeetCode's Blind Curated 75, where I'll be solving the all the open brackets are closed by the same type of bracket. One other thing to note is open brackets must be closed in the correct order. So this would be true, this would be true. So for closed parentheses, I'm going to match that with an open parentheses. So bear with me, this might take good, but otherwise string. First, we're going to check to see if it's a open parentheses or bracket. So if p in lookup, and notice that these are the values, then we'll simply append to our stack. Otherwise, it's a closed parentheses or bracket, right? And if that's the case,
It is a close. What? I still don't get it. This is so much more easier. It's easier to think, okay, if it is, shit, submission, solution.
Hey guys, Greg here. Some straight opening. We get to the end of the string, and we are done. We just maps each closing bracket. Put row in one map that we're dealing with. That's what this means. Well, we can immediately.
Bro, literally, what is going on? I should be able to do this apparently, but something along the skill tree makes me not do this.
And we want to make sure of negative map or means we learn this is also bracket. We know though if we keep going.
So what will happen is this will append. When it comes to this will be like, okay, does what the fuck is C? Why is it and -1? Ah. I wanna. So this is wrong, apparently. Okay. Ugh, black bitches are dumb. Black bitch. What? Okay, we got all of this. So that is if C. What is C? Oh, I wanna punch people. What if C? If C. Fuck you. Fuck you. Fuck you. Fuck you. Fuck you.